When a driver sees twisted metal tumble off a truck, they swerve instantly. But for an autonomous vehicle, that same anomaly triggers a crisis. The system's flickering bounding boxes reveal a machine struggling to decide if it's seeing a bicycle, a pedestrian, or a cloud of debris. This delay exists because today's AI models are built on a semantic bottleneck. The car must determine an object's name before it can calculate a path around it. In human biology, identifying categories is the job of the ventral stream, the LET pathway. It's effective for recognition, but it's slow. Yet almost every major self-driving architecture is modeled on this single, high-latency neurological process. Relying on a dictionary makes a vehicle fragile. If the system hasn't been trained on the specific name of an object, it lacks the logic to avoid it. Engineers attempt to fix this with more data, but the physical world is too chaotic to catalog. There is no exhaustive library of hazards. Processing trillions of labels creates a massive computational tax. When the part pauses to classify a pixel, precious milliseconds are lost. When the dictionary fails, the system flatlines. If the AI cannot categorize an object, it may ignore the obstruction entirely. Memorizing the universe is a losing strategy. By requiring a name for every obstacle, we guarantee the machine will eventually encounter something it doesn't recognize and fail. Human babies navigate living rooms long before naming the furniture. They move through complex environments without bounding boxes or a pre-programmed catalog of objects. We rely on the dorsal stream to track optical flow, the mathematical expansion of light as things approach. This is the logic of affordance. We stop seeing pedestrians and start seeing momentum and trajectory, allowing an instant physical reaction without identifying the source. Real situational awareness comes from calculating how an object will physically alter your trajectory, regardless of what that object is called. To replicate this, engineers are building machines that possess physical intuition rather than just a massive memory. Joint Embedding Predictive Architecture, or JEPA, allows AI to build internal world models. By watching unlabeled video, it tracks invisible forces. Predicting these hidden states teaches causal dynamics, internalizing gravity and inertia, instead of just memorizing the color of a bumper. The machine's world stops being a flat collection of 2D pixels. It becomes a three-dimensional environment, governed by physical laws that the AI can anticipate. We are moving past rigid dictionaries. We are growing an artificial physics engine inside the machine. Once a machine understands physics, the way it makes decisions changes. It stops following human-coded rules and starts following the laws of motion. Traditional models try to maximize a human-designed reward, which can lead to dangerous shortcuts. This new approach simplifies the goal. The system navigates by minimizing prediction error. Under active inference, the car predicts a continuous, safe path. A jagged anomaly creates a mathematical surprise, a gap between expected physics and actual sensors. To return to equilibrium, the AI swerves or brakes, instinctively altering its reality to match its safe prediction. Safety becomes a product of mathematical balance. The machine steers to maintain a state of physical equilibrium with its environment. This is the logic behind 4D occupancy networks and the emerging ISO 8800 standards. It is the transition from identifying objects to understanding space. The vehicle sees the world as a grid of 3D voxels. It ignores the brand of a car or the color of a jacket, checking only if a pocket of space is empty or occupied. This removes the noise of classification. The machine stops trying to define the world and simply starts navigating its density. It glides through chaos, guided by the flow of space and the physical constants of mass and motion. Reliability comes from learning the physical constants of the world rather than trying to memorize its vocabulary. The machine is finally learning how to physically live inside the environment it was built to navigate.